Hello students, welcome once again to our channel Score High to Soar High. In this video series, we have been uploading Tamil Nadu State Board Syllabus Class 12 Physics Unit 2 Current Electricity 2 3-mark question and answers. As a part of this, today we are going to see a few questions. This is the part 4 of this video series. Come on, let us continue with our studies. Question number 13. State Kirchoff's voltage rule or loop rule. Answer. In a closed circuit, the algebraic sum of the products of the current and the resistance of each part of the circuit is equal to the total EMF included in the circuit. So in a closed circuit, first we need to find out the products of current and resistances. Then again we need to add them all. That sum total is equal to the total EMF included in the circuit. This is what the voltage rule says. Now let us write the rule in the form of an equation. Sigma IR is equal to sigma eta. Here IR stands for the product of current and resistance, and this sigma is nothing but the summation of all the products of IR in the circuit, which is equal to the sum of all the EMFs in the circuit. Now let us see in detail about this voltage rule with the help of a diagram. With the help of this diagram, we are going to learn Kirchoff's second rule, in other words, voltage rule or loop rule. What does this rule say? In a closed circuit, the algebraic sum of the products of the current and resistance of each part of the circuit is equal to the total EMF included in the circuit. Now let us have a closer look at this diagram. In this circuit, there are two loops. In other words, there are two paths. Path number 1, EACE, and path number 2, ABCA. In the path or loop EACE, there are three resistances, R1, R2 and R3. Similarly, there are three currents, I1, I2 and I3. According to this rule, what we are supposed to do is, we need to multiply the resistances with their respective currents. In other words, I1, R1, I2, R2, I3, R3. Now we have got three products by multiplying the currents and their respective resistances. Now we need to sum them up. In other words, we need to add them up. That is I1 R1 plus I2 R2 plus I3 R3. This sum total will become equal to the EMF of the cell included in this circuit. That is, here in this loop or path, there is a cell named capital E. So the sum of the products of the currents and the resistances will become equal to E. Similarly, in the second loop or in the second path named ABCA, there are three resistances, namely R2, R4 and R5. Similarly, there are three currents, I2, I4 and I5. What we are supposed to do is, we need to multiply them up and find out the products. That is, I2, R2, I4, R4 and I5, R5. Then again we need to sum them up all. Then it will become I2, R2 plus I4, R4 plus I5, R5. Which will become equal to EMF actually, but in this case, in this loop ABCA, we don't find any cell at all. So there is no EMF in this loop. So we need to write them as I4R4 plus I2R2 plus I5R5 is equal to 0. As there is no cell, there is no EMF, so we need to put 0. Now let us see the equation. Applying Kirchoff's second law to the closed loop EACE, I1R1 plus I2R2 plus I3R3, which is equal to eta, that is nothing but EMF. And for the closed loop ABCA, I4R4 plus I5R5 minus I2R2, which is equal to 0, as there is no EMF. But here comes a small doubt. Why do we put minus for I2R2 but not for I4R4 and I5R5? Now let us have a look at the diagram once again. The direction of the current, in either way we can choose, either in the clockwise direction or in the anti-clockwise direction. It is left to us. Now let us take the current direction as anti-clockwise. So in this case, the current I4 and I5 are in the anti-clockwise direction, that is in the same direction. But what about I2? The direction of the current I2 is opposite to the directions of the other two currents, that is I4 and I5. That's why it is given minus sign. Hope you would have understood the Kirchoff's second rule.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.